Okay, Mr. Sonnenberg here. This is Science 9. We're talking about chemical reactions today. So we've moved on to General 2 of matter and chemical change, General Outcome 2. So we're identifying and evaluating dangers of caustic materials and potentially explosive reactions. Um, so we're looking at specific outcome 2.3. So we're observing and we're describing patterns of chemical change in two ways. One, by observing heat generated or absorbed chemical reactions. So these are things that we call exothermic and endothermic reactions. Then also we're identifying evidence for conservation of mass in chemical reactions. And we're demonstrating and describing techniques by which the evidence is gathered. So let's jump into it. So what is a chemical reaction? Okay, so this is something that it takes place when two or more substances combine to form a new substance. So we've had previous lessons where we've discussed physical and chemical changes, and so physical changes being that it changes in state, not composition, and then chemical changes that a new substance is formed. So here we're going to break that down even farther and discuss these chemical reactions. So there's different types of chemical reactions. We don't talk a ton about it in grade 9, but you're going to learn a lot more about it in grade 10 and through your chemistry in your high school. So these different types, so there's combination, decomposition, displacement, and exchange reactions. So when we have a chemical reaction occurring, what we do is we break it onto two sides of the equation. So the left side we call the reactant side, and the right side we call the product side. So basically the reactants are the substances at the beginning of the reaction. And then the products are the new materials that are produced by the reaction. Okay? And then obviously if you take a look here, we have this word called coefficients, which is an important word as well. And the coefficients are these numbers in front of the equations, okay, or the materials, okay, pure substances in this case. So reactants, okay, this is at the beginning, and the end product is at the end of the equation. So again, just going back, we've talked about what a chemical change is. Okay, so what happens is when we what happens is when the properties of the products differ from those of the reactants, a chemical change has occurred. So we take the reactants and the end result, the products, is different. Okay, so chemical change is going to result from a chemical reaction, and we're talking about chemical reactions. So remember some things, we did a lab on this already. We've discussed what chemical changes and how do we know there's evidence that this has occurred. So is there possibly one, there was a change in color, there was a formation of an odor or a foul smell, the formation of a solid precipitate or gas bubbles, okay, in the liquid, and the release of absorbed energy, or absorbed energy. So can we feel heat being given off? A flame burns, okay, a piece of paper burns. Is it easy to reverse? No, we can't reverse the ash back into paper. Is it giving off heat? Yes. Okay, a chemical reaction is occurring. Okay, is there formation of odor? Yes. So it doesn't have to be all four of these points in order for it to be a chemical change, but some of these points they are evidence that a chemical change is occurring. Now remember, the main thing is that a new substance is formed, so the products are different than the reactants. So I'll just show you a few examples. So we have the precipitate forming in the liquid. We have the fizzing or bubbling. We have vinegar and baking soda. And we actually looked at that in our lab as well. Paper burning here, it's giving off heat. And then if you take a look at this picture here, changing, reacting with components in the air to change color over time. So now here's two words that are going to keep popping their heads up as well. Exothermic and endothermic. So basically what we're talking about here is either the release or the absorption of energy. So we'll start with this one right here, this exothermic. So it is a chemical change which releases energy. Okay, so a release of energy is called an exothermic reaction. All right. Whereas the opposite to that, is an endothermic reaction. So that's a chemical change which absorbs energy. Okay, so exothermic is release, endothermic is to absorb. So if we take a look here, now we're talking about actually writing chemical equations. So these topics lead into, or chemical reactions and chemical equations lead into rates of chemical reactions and how do we speed them up, how do we slow them down, what are things we can do, and then it's actually going to lead into ionic compounds and molecular compounds as we get further into the unit. So chemical reactions can be written in different ways. They can be written as word equations. As we take a look right here, this is a word equation. Okay. This is going to give the names of all the reactants right here. Okay. And they're separated by a plus sign, notice, each of these, followed by an arrow. Okay. So it's not an equal sign because they don't equal each other. Okay. This is telling us that this is producing rust. Okay. This points to the names of all the products. So these are reactants on the left side that I'm circling with the mouse. Produces rust. So iron plus oxygen plus water produces rust. And again, I just have to keep bringing up my old Ford truck that I've drove to school a few times. Look at the driver's side fender. You see a little bit of rust on there. So, and again, we're separated by plus signs. Now, there's not always going to be just one product. There might be multiple at times. But left side of the equation is the reactant side. Iron and oxygen and water react to produce rust. All right, so one of the equations that we're going to really talk about is the combustion. It's going to be a combustion equation. So combustion is a chemical reaction that occurs when oxygen reacts with the substance to form a new substance and gives off energy. Okay, so it releases energy, so we call that exothermic. Okay, so let's take a look here. We have fuel, we have heat being given off, and oxygen is going to meet with the fuel and create that flame. Just show a little example here of another reaction as well, just in both a word equation, okay, and in a chemical equation. So there's different tests that we can do to identify what is being combusted. Okay, so we have identification test for oxygen. So we could light a wooden splint. We blow out the flame, allowing the splint to continue glowing. Hold the glowing splint in a small amount of the unknown gas, and if the splint bursts into flame again, then the gas being tested is oxygen. So we light it, we put it out, and then we put it back under the gas source, and if it lights back up or bursts into flame again, then that's oxygen. So this is one of the identification tests if we are dealing with oxygen. So the next identification test is for hydrogen. So again, we light that wooden splint, or a different wooden splint, hold the glowing splint in a small amount of unknown gas, and then if you hear a pop, then the gas being tested is hydrogen. So it's going to create that pop, which is different than the oxygen, which just lit back and burst back into flame. And another one here for the identification test is for carbon dioxide. So we take that burning splint and we put it in carbon dioxide. The flame will go out and you'll know the gas is not oxygen or hydrogen. Okay, remember oxygen would light back up, and or oxygen would, and hydrogen would make a pop, but you will not know for sure that it is carbon dioxide. So to test for carbon dioxide, is not a combustion test, but rather uses a liquid called lime water, a clear colorless solution of calcium hydroxide or slaked lime. So we bubble the unknown gas through the lime water solution, or add a few drops of lime water solution to the gas and swirl it around. And if the lime water turns milky, the gas is carbon dioxide. Okay, so that's a good test for the carbon dioxide. So these chemical reactions, they actually break chemical bonds. So the chemical bonds are forces that cause a group of atoms to behave as a unit. So this is what they binds them, right? So this energy is stored in these bonds, and in order to break the bonds, okay, we must add energy, okay? And when bonds form, energy is actually released. So all chemical reactions involve energy being absorbed, which is endothermic, okay, or released exothermic. So there's those terms again, okay? So release of energy is exothermic, and the absorption of energy is an endothermic, or is endothermic. So just two examples. Photosynthesis, okay, we know occurs in the chloroplast of plant cells, is an endothermic reaction. So it needs the light energy, or the energy from the sun, for it to occur. Whereas combustion is an exothermic reaction. And the reason for this is it gives off light and heat. So something combusts, bursts into flame. Well, we're giving off light, we're giving off heat, and you can feel the heat, say over an open fire or such, or something that is combusted, you feel that heat. So it's exothermic because it's giving off heat. Whereas photosynthesis is endothermic because it needs heat to initiate the process. So again, I've put some sources and resources. I have a couple YouTube videos that are relevant to this content that I believe will help you. Also, you can go to this site right here that I'm circling. That's going to also provide you with some information and such. So again, you can take your lecture notes from this slide on chemical equations and reactions, and there will be an upcoming screencast that is going to be discussing the rates of chemical reactions, how we can speed them up, how we can slow them down. Okay, so we'll see you at the chemical reactions and rates of reaction screencast. Okay.